In this question, it is given that water is moving with a speed of 5 meter per second through a pipe with cross-section area of 4 centimeter square. Water gradually descends 10 meter as the pipe increases in area to 8 centimeter square. The pressure at the upper level is 1.5 into 10 raised to 5 Pascal. The pressure at a lower level is. Just try to understand this question. Over here, water is flowing through a pipe which is kept in vertical position, not in horizontal position, and some amount of liquid is flowing through it. Now, if you are considering a cross-sectional area over here, let's say this cross-sectional area is equal to, take it as 4 centimeter square, or you can write 4 into 10 raised to minus 4 meter square, where the velocity of liquid is nothing but 5 meter per second. The water gradually descends, so if it is moving in downward direction by a distance, let's say which is given as nothing but 10 meter, the pipe increases its area to 8 centimeter square. So we can take it as area of cross section over here is 8 into 10 raised to minus 4 meter square. The pressure at the upper level is, so pressure over here, take it as P1 is given as nothing but 1.5 into 10 raised to 5 Pascal. The pressure at lower will be. So our aim is to find out what about the value of pressure over here. Let's say pressure is equal to P2. So what we can do is, we can apply Bernoulli's theorem between point 1 and point 2. So for writing Bernoulli's theorem, I'm just taking this as our reference line. Okay? So I'm just going to write this as nothing but our reference line. So I'm just writing it as pressure at point 1 plus half into rho into V1 square plus rho into G into H should be equal to constant, or you can write this is equal to pressure at point 2 plus half into rho into V2 square plus rho into G into H2. So the we can find out the value of velocity just by using continuity equation over here. So first we can just find out the value of velocity by using that equation A1 V1 is equal to nothing but A2 V2. Now we can observe that this area is increased by 2 times. So definitely this velocity is going to decrease by 2 times. So I'm just directly writing it as velocity V2 is initial velocity was 5. So it is going to decrease by 2 times as area is increased by 2 times. So we can write velocity over here is nothing but 2.5 meter per second. Now we can just put this value to find out the value of pressure at point 2. So pressure at point 1 is given as nothing but 1.5 into 10 raised to 5 plus velocity over here we can take it as half into rho density of water, we can take it as 10 raised to 3 or 1000 into V1 square. I'm just writing this V to this term on the left side, so it is going to be half into rho into V1 square minus V2 square. So V1 square is nothing but 5 square, which we can take it as 25 minus V2 square is nothing but 2.5 the whole square, that we can take it as 6.25, and plus rho into G, I'm just taking it as rho as nothing but 10 raised to 3, G we can take it as 10, and this H1, that is height from this particular point, we can take it as H1 is equal to nothing but 10 meter, and H2 we are taking this is our reference line, so H2 will be equal to 0. So we can write this is half rho into G into H1. H1 is nothing but 10 should be equal to the value of pressure P2 over here. Now while solving this, we can find out the value of pressure P2. So we can write this is nothing but 1.5 into 10 raised to 5 plus 25 minus 6.25, which is 18.75 divided by 2 will get us around 9.375 into 10 raised to 3 plus this we can take it as 10 raised to 5 is equal to the value of P2. So we can write is 1.5 into 10 raised to 5 plus this can be written as 0.09375 into 10 raised to 5. I'm just writing it all in terms of 10 raised to 5 so that we can take this 10 raised to 5 as common and we can write the value. This is going to be 1.5 plus 0.09375 plus 1 into 10 raised to 5. So I'll get the value of P2 is equal to around 2.59375 into 10 raised to 5, or you can approximate it as around 2.6 into 10 raised to 5.